Mobility is extremely valuable, but transportation is not homogeneous. You've got light-duty transportation, personal transportation, you've got transportation of freight, aviation and marine. And the challenge is going to be finding the right technical and economic solutions for each of these forms of transport whilst minimising the impact on the environment. Transport, according to European Union figures, should be 50 to 60% reduction in greenhouse gas emissions. In the light-duty transport section, there may be alternatives with electrification, particularly in cities.
Everything comes into play. We are seeking to make lighter vehicles, to replace steel with composites, to use batteries as the primary source of power.
Electrification, extremely challenging at the moment unless we have a breakthrough in energy storage, which means that increasingly as we look out to 2050, I think we're going to see oil still as a major part of the transportation industry.
So it's Shell's view that oil-derived fuels will dominate the transport sector out to 2050.
The targets of an average 50 or 60% sustainability with a significant amount of second-generation biofuels by 2020 looks very tight at the very best.
The primary technology challenge is and will remain for quite some time delivering more fuel economy, better fuel economy through our lubricants. The preferred route that Shell has for addressing these challenges in developing future lubricants is to work in a co-engineering way with automotive manufacturers. Co-engineering to us is designing the lubricant at the same time as the engine. It's treating the lubricant as an engineering component within the engine. And whilst this adds some complexity in that we have to start the design of the lubricant at an earlier stage in the engine design, what it does result in is an optimized lubricant that's really tailored to suit the specific requirements of that automotive OEM. Working with science in close collaboration at the very early stages of development provides insights that guide long-term developments for our industry.
The work we're doing in collaboration with academia really underpins all the research and development we're doing at Infineum. It ranges from development of new lubricant additives, automatic transmission fluids, understanding what happens in an engine at the surface, right through to the development of new fuel additives. And the aim of this work is actually to relate what happens at the molecular level and the underpinning science to the properties of the products we actually develop. A meeting such as Illuminating the Challenges in Automotive Research is really unique in this industry. It brings together fundamental scientists such as the physicists at Diamond with people from the industry such as the original equipment manufacturers, vehicle manufacturers and lubricant companies.
You know, people do chat, do get the chance to meet and to in fact see where there is sort of overlap, where there is interest. This is where the initial contacts are made, and then a few years down the line, you know, with maybe a few other additional experiments, you know, these sort of ideas or these contacts can often blossom into, you know, full-blown projects.
One of the questions that we are always asked is, well, how can science help the automotive industry meet the challenges that it faces now and also in the years to come?
For a large part, when you're trying to manufacture something on a large scale, you know, some of the issues of where the real atoms are, you know, at the nanoscale or at the atomic scale may not appear so relevant, but for sure they will do. I mean, ultimately, if we're talking about making a society that's more atom efficient, we have to know really what's going on at those sort of scales.
If you want to solve a problem, then you need to understand it first. And what we provide is an improved understanding of those challenges. And then we just allow people to be creative and find the solutions for themselves.
From our perspective, from an academic perspective, it is also important to see the bigger picture. And I think that's where these sort of meetings have a key role, because effectively people are given their chance to kind of pitch, if you like, the research ideas that they have, or, for example, from an automotive industry perspective, you know, where they're at, what the challenges are that they face in the near and in the distant future.
Diamond's a fantastic facility to have right on our doorstep, and it's great to be able to come here and access really truly world-class facilities. The research that we do is looking at electrochemical devices, lithium batteries, hydrogen fuel cells, electrolyzers, supercapacitors. By combining the chemical information that we get from I11 and I12 with the microstructural information we get from I13, we're building a picture of these electrochemical devices from the crystal structure up to the device level.
For the gold standard of X-ray investigation, we need synchrotrons such as Diamond, which give access to the full range of techniques, including X-ray imaging and tomography, X-ray diffraction, and X-ray spectroscopy. We use many of the instruments in the arsenal of Diamond, including spectroscopy beamlines that we, for example, employ to perform careful analysis of absorption in battery materials.
Diamond for us is really a core facility for our research, and that is because we rely on X-rays for effectively structural characterisation of materials.
We use high energy beamlines such as I12 JEEP for diffraction and imaging, and we use test beamlines such as B16 for developing new methods and techniques. And altogether, this provides us with the cutting-edge insight into material performance under realistic conditions across the scales.
Nowadays we're looking at kind of atom counting, and where every atom is in three-dimensional space is important for understanding why a material is good or not. And Diamond has a suite of facilities that we typically utilise and has quite a degree of expertise and certainly also a lot of, in some areas, niche capability for us to kind of really carry out very unique experiments.
With increasingly stringent legislation in terms of emissions, in terms of fuel economy, coming in across the world, it's really vital that we engage with science and collaborate to devise real-world solutions to these challenging problems.
With 9 billion people in the world by 2050, the energy demand expected to potentially to increase by 50 to 100%. We're going to need all forms of energy. So the critical thing is using the right energy sources in the right places. And it's clear that oil has a lot of advantages in transport. Some great research and development going into second generation biofuels, and they will come good eventually. But it's like everything, you can't necessarily force technology by putting a mandate on a date. You need to promote it, research, help it out, but then you need to wait. And you have your best brains working on it, but you need to wait until it becomes mature.